Adding and subtracting polynomials. I'm not used to having an audience when I record. This may be helpful. Welcome. Yeah, live studio audience. All right. So, guys, we've been working with monomials, right? And their characteristics. Now we're going to switch to polynomials. So can you imagine what a polynomial is? It's going to be monomial had one term, right? So a polynomial is going to have more than one term. All right? Here are your vocabulary words: polynomial, binomial. You can imagine, I think, what binomial might mean. Bi meaning two, trinomial meaning three terms. We're going to learn what the degree of a monomial is. We're going to learn what the degree of a polynomial is. We're going to learn standard form for a polynomial. We've learned standard form for a linear equation, and we're going to learn what the leading coefficient is. So those are our several terms that we'll get through in this section. I could say that Chapter 8, what's the title of Chapter 8? Just so you get the idea. We're going to be talking about quadratic expressions and quadratic equations. So we're getting into the serious stuff. All right. A polynomial is a monomial or the sum of monomials. So it's a monomial, as we've talked about. Oops, let me get my highlighter going again. So a monomial, as we've talked about before, is one term. A binomial is going to have two terms, 1, 2, and there's going to be an operation in between. And obviously a trinomial has 1, 2, 3 terms. And it's the sum of 3 terms. The sum, of course, means it could be addition, but as in this one here, it also could have subtraction, because we know subtraction is really x cubed plus a negative 10x plus 1, right? So really subtraction is just a different form of addition. So it fits the definition that it is the sum of 3 monomials, or 3 terms. The degree of a monomial is the sum of the exponents of all of its variables. So if it's the degree of a monomial is the sum of the exponents, okay? So if you had x squared plus y, plus 2x, we'll see that there's an exponent here. We know there's an exponent there that we don't write, and we're going to be talking about the sum of those exponents. We'll talk about that more in a minute. The degree of a polynomial is the greatest. Let me say that again. I just did that incorrectly. See, this is where if I wasn't recording before a live audience, I would stop and start over again. So you guys are experiencing this live. So the degree of a monomial is x squared y cubed, right? And that would be the sum of those variables. The degree of a polynomial is the greatest degree of any one term. Okay? And polynomials are named based on their degree. So if it has 0 degrees, it's a constant. And an example of a constant would be 4, or any number. The degree of 1 is called a linear, its name is a linear polynomial, because say we have 2x plus 7. The greatest degree is 1. So it's called linear. Quadratic, it has 2. The greatest degree is 2. And so on. Cubic is 3. Quartic is 4, and quintic is 5. But really, this is what we're going to be focusing on in this chapter. And if they're greater than that, it's to the 6th degree or to the 7th degree. And this chart is also in your book, so if you don't have time to copy it down now, or if you want to pause the video, if you're watching the video, you can do that. Okay, so here's what we're going to do. We're going to determine we're going to look at this expression. We're going to determine if it's a monomial, a binomial, or a trinomial. And we're going to figure out the degree, and we're going to figure out the type. Okay, so in this first one, A, we have 4y minus 5xz. And what is this? Is a monomial? Is this a polynomial? Well, yes, it's a polynomial because it's terms that are added together. So we can say, yes, it's a polynomial. And what degree is it? It's the sum of, it's going to be the sum of 4y and 5xz. So they're going to be 2. And the type will be a binomial. Negative 6.5, is this a polynomial? Anybody want to contribute here? They can. Yes, it has one term. Okay. A monomial is a polynomial. It's the first kind of polynomial. Then binomials, trinomials. Okay. And how many degrees? What are you guys thinking? Anybody have any idea? There are no degrees. Remember back one chart. It's negative. It's a constant. It's a whole number. So there are no degrees, right? And what type is it? We just talked about this. It's a monomial. Okay? 7a to the negative third. Is this a monomial? Look carefully here at this part of this expression. How do we really write 7a to the negative third? 1 over 7a. Is that the sum of anything? No, so it is not a polynomial. It has to be the sum of things. It can't have division. You know, if this a were on top, we would have been okay, right? Does that? Okay, okay. And what else? This last one. So here, is this a polynomial? It's all sums, right? Everything's being added together. No division of variables. So yes, it's a polynomial. It's all being added together. And the degree is, what did that chart tell us back here a second ago? Remember, the degree of a polynomial is the greatest degree of the first, oh, sorry, I don't have my highlighter on. The greatest degree of the first term. So what's the greatest degree? What's the first term? No, the degree of the term is going to be the exponent. So the greatest degree is 3. And so what type is that? That means it's a trinomial then. We'll have these on worksheets tomorrow, and you'll get more comfortable doing them. It's one of those things, you practice them a little bit, and you get more comfortable. Okay. Here's some practice problems. You guys in the room, I suggest you just go ahead and write the practice problems down quickly, and then you can go back and try them later, because I'm going to move on fairly quickly. Everybody else who's listening to the video can pause the video. So you have to do the same thing we just did. Is it a polynomial? What kind is it? And to what degree? Just like we just did in those practice problems. So 1a is x, 1b is negative 3y squared minus 2y plus 4y minus 1, if this helps you guys in the room. C is 5rx plus 7tuv, and d is 10x minus 4 minus 8x to the, I think that's to the a degree. This is an A. Okay? All right. Good luck with those, and we'll talk about them tomorrow or the next class. All right, misspell, standard form of a polynomial, not standard from. Standard form of a polynomial, all right? With the standard form, you always go in greatest degree order to least degree order. So x cubed comes before x, so x cubed comes before the x squared, becomes before the x, comes before the constant. All right, and this guy right here, here's your other definition, is called the leading coefficient. So actually not the whole guy. The 4 is the leading coefficient. Right, and 3 is the greatest degree, so it goes first. Okay, so we're going to go, and then we'll go in descending order. Okay, and those are the characteristics of standard form. And that's usually the way you see it written, and that's usually the way we're going to work with it. Okay, so one of your homework things, worksheets tomorrow or next class will be write each polynomial in standard form and identify the leading coefficient. Okay, so this is fairly straightforward, it seems like, but be careful of the negative slash subtraction sign, right? So first of all, we're going to put them in descending order. So 4 times x to the 5th, right, is our greatest coefficient. And what's our next greatest will be 3x squared minus 7x. By the exponents, the descending order, of the exponents. So your greatest exponent goes first, and so on. All right, looking at the next problem. Same thing. What is our largest exponent? It's going to be here. Negative 2y to the 4th is our largest exponent. Make sure that negative sign goes with it. And then the next one will be this guy, so it'll be minus 6y cubed plus 5y, and then minus 9.
So how do you decide when it's like
5y and 9. 9 has no exponent. 9's a constant, so it always goes last. This does have 1 degree. Okay? So we go 4, 3, 1, none. Here's your guided practice. I'll read these out for you guys in the classroom right now. 2a says 8 minus 2x squared plus 4x to the 4th minus 3x. 2b is y plus 5y cubed minus 2y squared minus 7y to the 6th plus 10. Okay, do those and pause the video and start it back up when you're ready. All right. And I think this is the last thing. Well, we're going to learn 2 things. We're going to learn how to add and subtract these polynomials when we have groups of them. So first, let's start with adding polynomials. There are 2 methods. You can use a horizontal method or a vertical method. We're going to start with a horizontal method. So here we have this polynomial and this polynomial. If we're using the horizontal method, in both cases, the first thing you're going to do is combine like terms. So we have a 2x squared. I'm going to start with that first term. And I notice, let me actually rewrite this. I'm going to extend this page. 2x squared plus 5x minus 7. And we're adding that to 3 minus 4x squared plus 6x. So I'm going to combine the like terms. So that's 2x squared and minus 4x squared. Make sure you take those components that are right in front of the terms with them, okay? Plus 5x. Do we have any x's over here? Yeah, we have a plus 6x. So we're combining those terms, and we're going to add a negative 7, and we have a positive 3. Seems a little tedious to regroup like this, but as you can imagine, you can get lots of terms and it can get fairly confusing. This helps you keep them sorted out. Now we can look at each of the like terms. 2x squared and a minus 4x squared is going to be a negative 2x squared. And 5x plus 11x is going to be, 5x plus 6x is going to be 11x, and negative 7 plus 3 is going to be minus 4. So there we've simplified this, we've added these polynomials and simplified them, okay? Then that's called the horizontal method. That's where they're all written out horizontally and you find your like terms and put them together. Vertical method's a little bit different. Vertical method, you're going to take your terms, I'm going to put them in order in standard form first. So I'm going to take this first component, or this first expression, write y squared plus 3y minus 5. And then I'm going to take the second one. I'm going to add them together vertically, but I'm going to put the like terms together. So we have a 2y cubed. That's going to go under that y cubed one. Here I notice that I have a y squared term. I don't have a y squared term in this first one. Oh, it's 4y squared, sorry. 4y squared here. I'm going to have to hold that place with a 0y squared there. Sorry, can you read that? Now I have a 3y, and I have a negative 4y. I have a plus 8. Actually, the plus 8 goes down below. I have a minus 5 and a plus 8. I'm going to rewrite this because I don't like how it looks. Plus 4y squared. Okay, so now we're going to add it vertically. See, we're going to add, maybe I'll change pen colors. We're going to add each of these things that are like terms. You see how it's going to work in a vertical method? So y cubed and 2y cubed is 3y cubed. 0y and 4y is going to be plus 4y squared. Negative 3, positive 3 and negative 4y is going to be a negative y. And negative 5 plus 8 is going to be plus 3. And there's the addition of those two polynomials. Okay? What's our study tips say over here? Let's see if I can move it a little bit. It says, notice that the polynomials are written in standard form with like terms aligned. Since there's no y squared term, we added a placeholder. And we talked about that. Okay. You can subtract a polynomial by adding its inverse. Okay, so let's see what that means. To add the inverse, you're going to write each term in as its opposite, okay? So, for instance, if we have, let's see. Okay, and this is just a little study tip. To do the additive inverse, you can also multiply every term by negative 1, or you can just change every sign in the term. So here we have 3x squared plus 2x minus 6. Oh, they're just showing us. So the additive inverse for that is times everything by negative 1, right? And you get negative 3x squared minus 2x plus 6. Okay, so that's the additive inverse of our original expression. Okay, let's see how we use that in subtracting polynomials. Okay, here we have the horizontal method. So we'll have 3. Just because I'm more comfortable with this, the first thing I'm going to do is I'm going to put it in standard form. 2x squared minus 2x plus 3, right? Minus 3x squared plus, minus 3x squared plus 4x minus 5. Okay? Now, remember, that's like there is a negative 1 here, right? So we're really changing all of these terms. So we're going to rewrite this as 2x squared minus 2x plus 3. Nothing happens there, right? We're going to add the opposite, minus 3x squared minus 4x plus 5. Everybody got that? Does this make sense? I mean, we've done this before when we've had that minus sign. We have to change everything inside, like when we were just doing linear equations with two properties, and you'd have to distribute something negative. You'd move that sign inside. Okay, now we're going to find our like term. So we have 2x squared. Do we have another square, x to the second power? Yes, we do. Minus 3x squared. And we have plus negative 2x, and we have a negative 4x plus our constants, 3 plus 5. Negative 2x squared minus 3x squared is going to be negative x squared. And we have negative 2x plus a negative 4x. That's going to be minus 6x. And 3 plus 8, or 3 plus 5 is 8. Notice in here that I had negative 2x plus a negative 4x, which meant negative 6x, right? Well, plus a negative 6 is like subtracting negative 6x. So then you revert it back to this when you're writing that final expression. Questions? Good. Good audience. All right. Vertical method. Okay, first let's get everybody in standard form. So we'll put our 4p cubed. Do we have any squareds? Well, we are going to have, I look and I see that there's a squared. There's none in the first one, in this first one, but there is a squared in the second one. So I'm going to go ahead and write my placeholder, 0p squared, and then I have plus 7p minus 8. And then I'm going to, oh, we're doing vertical. My bad. Okay, we don't need the parentheses. Now we're going to subtract, but remember, we're going to add the inverse, right? So I'm going to actually add all the opposites. So it's going to be, there is no p to the q, to the third power, so I'm going to write 0p. We do have squared, right? It's 3p squared, but it's going to be a minus 3p squared because I multiplied it by negative 1. And we have a negative 9p, but I'm multiplying by negative 1, so it's going to be plus 9p. And we have a 2, which will change to minus 2. All right, again, remember we're going to add all of these guys. So 4p and 0p is 4p cubed, and 0p and 3p is minus 3p squared, and 7p and 9p is plus 16p, and negative 8 plus a negative 2 is a negative 10. And that looks like it. We're in descending order with our exponents. And our leading coefficient is 4. Our degree of this polynomial is 3. Okay.
Do you need the vertical method versus the horizontal method in any specific situation?
Not that I can think of off the top of my head. Andy just asked if you need the vertical method for some sort of thing. So Andy gets the call out today, and everybody's looking at him and smiling because he's so lucky. Yay, Andy, Edward says. Do you need the vertical method sometimes and the horizontal method sometimes? Not that I can think of. It's just either way, whichever way you prefer to think about doing this it's your choice on which method to use. If it's confusing, just learn one method. Don't worry about the other method. Here's your guided practice. 4a is 4x cubed minus 3x squared plus 6x minus 4 minus, parentheses, negative 2x cubed plus x squared minus 2 end parentheses. B is parentheses 8y minus 10 plus 5y squared minus parentheses 7 minus y cubed plus 12y in parentheses. So this section is really like a sorting game. You know, you have to look for the patterns and look for the pairs and look for the matching things and combine them. It's not very hard math right now. It's really about looking carefully, paying attention to details. And probably the hardest thing is these negatives here with these negatives here and thinking about what all those terms mean when you do the inverse. So good luck with that. And we have a real world problem. How exciting. Oh, you should see the faces, guys. Mary Elena just made the most awful face. All right. The equations P equals 7m plus 137 and C equals 4m plus 78 represents the number of cell phones, P, and the number of digital cameras sold in the number of M months at an electronics store. Okay? And we're asked to do, this is not hard. Write an equation for the total monthly sales for phones and cameras. Duh. So what we have is we're going to have phones plus cameras equals the total sales, right? Well, we can substitute in what is P, what's the total number of phones? It's 7M plus 137, right? Plus C, which is 4M plus 78, is going to equal the total number of sales. This is not hard. I don't know, but I think Andy just took a picture of himself, but I'm really not going to ask. Oh, he took a picture of the board. Okay. Okay. TMI. All right. Right. Okay. Oops, sorry. So then we just combine our like terms, right? 7M plus 4M. I'm insulting you by even doing this because you guys can solve this one. So I'm just going to leave it there. Call it the end of this presentation. So good luck with this, and we'll talk about it next class.